today. This is section 2-4 and 2-4. And, oh, hopefully it won't be too painful and some of it be familiar. This is another look at linear equations. So I will just call it more stuff about linear equations. Linear graphs, okay? So if I see something that looks like this, boom, let's put lines on the end. Here's a graph. Oh, here's this. And then I have a graph going across in a different color, like here. And I know that this graph goes through the points, hey, -1, 2, and 3, 2. Let's say this is a point 3, 2. What's the slope of this? What's the slope of that line? Yes, Sophie.
0.
The slope equals 0. So I could try to put this into my y equals mx plus b, y equals mx plus b form, okay? But what goes in there? 0 goes in there. And what goes in there for b? 2, okay? So you could do that, and you come up with the equation just y equals 2, right? So that's the equation of any horizontal line, right, has the equation just y equals something. You should be writing stuff down there, you kids. Y equals something. So y equals 2. So you could go through and say, well, I can figure out the slope and go this minus this is 0, this minus this is 4, and find the slope of the line and find the y-intercept, which is going to be 0, 2, and then plug it in. Or you could just know that the equation of a horizontal line is just y equals 2. Because no matter where I go on this line, what's y always going to be? It's always going to be 2, okay? So say I had another horizontal line that looked like this, and all I have down here is this horizontal line, and I know that it goes through, let's say it's horizontal even though it doesn't look perfectly horizontal. Let's say it goes through this point 0, -4. Who could tell me the equation of that line? Equation? Jake?
Y equals -4.
Right, y equals -4. Simple enough, okay? So when you have a horizontal line, the equation is just y equals whatever the y-intercept goes through. Write down stuff. It makes sticks in your brain if you remember it, okay? Okay. What about if I have vertical lines? Let's draw another graph. Here's another graph. Here's another graph. Here's a vertical line that, let's make it a different color. Let's make it dotted or something like that. Here's a vertical line, and let's say it goes through the point, let's say this point on here is 3, 4. And this point over here is 3, -2. How do I find the equation of that line? What would be the slope? Well, the slope would be undefined, right? Because it's 4 minus 2 divided by 3 minus 3, which is 6 over 0, which means the slope is undefined, means it's infinitely steep, right? But no matter where I go, what is the x-coordinate equal to? X equals 3. So that's just the equation of that line. No matter where I go on this line, x is always equal to 3. Oh, what happened there? It doesn't matter what y is equal to, x is always equal to 3. Okay? So for a vertical line, I'd write it down. Vertical line, x equals, okay, x equals how far it is from y-axis, okay? X equals how far from y-axis. Well, you shouldn't really say how far because that implies absolute value, but it has to do with the sign. So what if I went over on this side and I were to draw a line? No, I want to draw a line. I want to draw a line over here. What would be the equation of this line if it's a vertical line and it goes through, I'd say this is -2, 5, and -2, -6. Who could tell me the equation of this line right here? Piece of cake. Yes, Ian? X equals negative. Is that difficult? Okay. So if it's a vertical line, it's x equals. If it's a horizontal line, it's y equals. Okay? Easy enough? All right, so we'll have some practice on those later on. So find the slope of it. You try, okay? Let's try this one. Couple practice problems. I'll give you a point. Find the slope. Find the slope. Practice problem number 1. Y minus 3 equals 5. You can tell me what the slope is. Kaylee. The equation is y equals 8, but what does the slope look like? Y equals 8 is horizontal line or vertical line? It's a horizontal line, so what's the slope of that? 0, okay? Slope is 0, right? M equals 0, because if this were the point 0, 8, right, it always go through there, okay? Who could tell me the equation of, or not the equation, find the slope. Slope, x plus 3 equals 11. Who's got that one? X plus 3 equals 11. X equals, that's not the slope though. If x equals 8, what's the slope? Not 0. If x equals 8, what's the slope? Undefined, right? It's undefined slope. It's a vertical line, the slope is undefined, right? Because you'd fall off a cliff if you tried to do x equals 8. Sorry, Meryl, I forgot your name. I'm old. How about this one? 2x minus 17 equals 3. 2x minus 17 equals 3. Slope. Who's got the slope? Go ahead, Ian. Very good. Undefined, right? Because it's going to be x equals, right? If you solve this equation, get x equals 10. Hey, I owe you a point. How about 3 minus 2y equals 16? Find the slope. Slope.
0.
Quinn. 0. 0. Okay. Slope is 0. Okay, we got that? All right. I'm giving you valuable participation points. Who's that? Ian and Meadow tried. I owe Meadow a point for forgetting her name. And I owe Ian Klingensmith a point. And I owe Jake A a point. Is that who I owe a point to?
Yeah.
Okay. So now we know that. I just lost my pen for my Moby board. Very nice. So let's move on to bigger and better things. So say I were to have a graph that looks like this, using intercepts to find equations of, two graph lines. say I have an equation 3x minus 5y equals negative 15. And they say, well, that's what happens when I don't look when I'm writing. Equals negative 15. And they say sketch the graph. Okay? So I'm gonna, where'd my stuff go? Not there. There it is. And they say graph this. Oh, look at my x's. These look kind of funky. That's okay. Anyone know a quick way to graph that? Rather than put it into y equals mx plus b form? Anyone know? What do you think?
Is 3 the x value and 5 the y value?
Is 3 almost is 3 the x value, and what I would do, you can find the intercept. I think you're on the right track there. So if this is x and this is y, right? When x is 0, what would y be? When x is 0, what would y be? 3, right? When y is 0, what would x be? When x is 0, y would be 3. If I were to cross this out, sometimes we call it like the cover-up method. How can I find a cover-up method? So if I were to hide this, okay? Let's just, here, we'll take a little polygon and we'll fill it in. We'll make it a box. Rectangle. And I'll fill it in my rectangle. Okay, so here's a little rectangle. Okay? And if I take my little rectangle and, take my little rectangle and bring it, cover up this, okay? I'm going to cover up that. 5 times what number gives you negative 15?
What?
3, right? So I have 0, 3. Now I cover up my y, okay? 3 times what number gives you negative 15? Negative 5. So I could put a negative 5 in here, and this is called your y-intercept, right? And this is called your x-intercept. And those two things, using those two things, it should be pretty easy to graph. The y-intercept is 0, 3, and the x-intercept is negative 5, 0. 1, 2, 3, 4, 5. Let's pretend this is negative 5, 0. So here's 0, 3. Here's negative 5, 0. And then quickly, I can sketch a graph of that, okay, and go right through those 2 points. Perfect, isn't it? Let's try that again. I just missed by a little bit. There we go, through those 2 points. And there's my graph of that one. See the way you can do that pretty quick? Okay, call that like the cover-up method or finding the x and y intercepts. So what if I said, real quick, graph 2x plus 4y equals 8. And I kind of do the same thing. I make a little table, okay? So when x is 0, so just take, you could use the cover up, just when x is 0, what's y going to be? 2, okay? So I know that I have 1 point on here, 0, 2. When y is 0, take your little rectangle or your hand or whatever. What happened? So if I were to cover up, where's my arrow? There, this. If I were to cover up my y's, when y is 0, what's x? When y is 0, what's x? 4. So those are my 2 intercepts, right? So I could graph them 0, 2, right? And 4, 0, 1, 2, 3, 4, 0. And then I could graph pretty quickly a line through those 2 points, okay? Get it? So if an equation is in this form, we call this, a lot of times they'll call this standard form, rather than y equals mx plus b form, standard form. It's really easy to graph by finding the x and y intercepts. Done? We're good with that? Good. What else do I got? I have a couple more things. Parallel lines. Anyone know anything about parallel lines? Parallel lines and their slopes. Anyone know? What do you know, Ian? Same slope. Okay? I think most of you know that. Same slopes. So, for instance, if you have two equations, y equals 3x plus 1 and 2y equals, or 2y equals 4x plus 7. How could I get this one? That's not right. 2y. Oh, sorry. I meant to put a 2x over here. Sorry. That should be a 2x. Okay. How do I put this into y-intercept form? Slope-intercept form. What would I do to get this into y equals mx plus b form? Yes? Divide both sides by 2. Okay? So if I did that, this becomes y equals 2x plus 7 divided by 2 is 3.5. So both of these equations, if I were to graph them, would have the same slope. They just have different y-intercepts, right? So 2x, it's a slope of 2, and one would go through 3.5, and the other one, would go through 1. That's not 1, is it? Okay? I have to take that and slide it up or something. There. Okay? So here is, so one of them would go through 0, 1, and one of them would go through 0, 3.5. Anyone know what happens if you have a line that is not parallel, but anyone know what that's called? When it goes through at a 90-degree angle like that? What's that called? Yes. Mandy. Oh, the other Mandy. Wait, Amanda. Amanda.
Yeah, it's called perpendicular.
That's called perpendicular. Anyone know anything about the slopes of perpendicular? Opposite what? It's opposite something else. Jessica?
Would like in that case the slope would be -2.
Not quite. They're opposite reciprocals. Okay? So so perpendicular lines have opposite reciprocal slopes. Okay? So if this has a slope of 2 over here, if this has a slope of 2, this would have a slope of m equals negative. The reciprocal of 2 is 1/2, and you make it opposite as well. Okay, so you make it negative and you flip it. Okay? So for example, say I know that so some line has a slope of 3/4. What would be the slope of the perpendicular? Slope of the perp. Anyone? Allie. Negative what? Yep, -4/3. You flip it and you make it negative. Okay? Have you done that before? Did you know that? You should write that down. You should write that down. Slopes of parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. What's the opposite reciprocal? What's the opposite reciprocal? Opposite reciprocal of -1. Anyone know what the opposite reciprocal of -1 is? What do you think there, Allie? What do you think, Calvin?
Positive one.
It's positive 1. Because -1 means -1/1, right? So I take it and I flip it over, so that's 1/1, just plain old 1/1. What's the opposite reciprocal of 6? -1/6. -1/6. Okay? So if I have a line that is a really steep slope of 6, a slope of a line that's going to be perpendicular to that, kind of makes sense, right? Whoops, that's -6. So if that's -6, then this would have a slope of +1/6, right? -6 up 1/6 if it's perpendicular. Okay? Too much work already? Too many things? What's wrong? You have a question, Chase? All right. So I'm going to do 2 more little example things. This sheet should have been cut in half, so you really only need the top half of it. But I punched holes in it because there's just one problem that we're going to do on the back and 2 problems on the front. So we're going to do those together, and then we'll do this little activity, and then you'll be on there. Okay? So 1, 2, 3. 1, 2, 3, 4. What's wrong? What are you looking at, Will? You're welcome. So, being the cutting edge math teacher that I am, I already scanned this in somewhere to my Schoology page. Oh, I better hit pause. So, one way to solve equations, like I know you guys know how to solve this using algebra and stuff, but another useful technique is to solve things algebraically, okay? And the way I would solve something like this algebraically is to graph this line. So what is a line that, well, where did it go? Disappeared. There it is. What is a line? Come on, buddy. Did you do it? No. Maybe I think maybe I have to capture this first. Place capture. So, what does a line with a slope of 1/2, what does this line look like? What does this line look like? What's the y-intercept? 3. So I go up to 3, and it's got a slope of 1/2. So I go over 2 and up 1. Over 2 and up 1. Over 2 and up 1. This is good practice for graphing lines. So let's see how accurate I could be. There's a pretty good line. Could you graph that line on your own? Yes? What is the line? So then, what does the line y equals 2 look like? What does the line y equals 2 look like? Horizontal or vertical line? Horizontal line. Y equals 2 is a horizontal line. Come on, quit doing that, would you? Is a horizontal line that goes through 2. Okay, so if I were going to draw that line, it looks something like this. Okay? So a point where those 2 things cross, right there, that's the solution to this equation. What is that point? What is that point? -2, comma 2. Okay? So where do they cross? When x equals -2. If I were to solve this equation algebraically, let's just do it to show you that. 1/2 x plus 3 equals 2. How would I solve this equation? What would I do first? What would I do first? Jessica? subtract 3 from both sides, okay? So that gives me 1/2 x, that goes away, equals -1. Then how do I get rid of this 1/2? Multiply both sides by 2, okay? By 2, okay? And this goes away, and I get x equals -2, okay? Look over here, x equals -2. See that? So you can solve equations, so for algebra, for linear equations, it's not that great a strategy, but when we get into different types of equations, like parabolas and cubic equations and other types of equations, sometimes the only way to solve them is using graphs. Yes?
I'm sorry, how did you get the equation
Y equals, so you could break this into two separate equations. One equation is y equals 1/2 x plus 3, and the other equation is y equals 2. See, from this side, well, you just make it into two equations. You said this side equal to y, and this side equal to y, and then you want to see when those two equations are the same. So I graph this side, I graph this side, and I see where they cross.
Wait, x or y?
What?
X or y?
You're trying to find x. Okay, so you make this equation y equals 2, and you make this equation y equals 1/2 x plus 3, and then you see where the two equations intersect. So we'll do another one. Okay, so where's that other one on your sheet? I have it somewhere, right? This one. Let's grab it, and this isn't the same one, is it? Solve. And so with this one, I want to graph the two equations that I want to graph are y equals 1/3 x minus 2 and y equals 1. How do I graph y equals 1/3 x minus 2? What's the y-intercept? What's the y-intercept? -2. So I put a dot and -2. From that -2, I'm going to go over 3 and up 1. Over 3, up 1. Do it a couple times so your graph is accurate. And then just connect the dots. Okay? Boom, 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 boom. There you go. What does y equals 1 look like? What's y equals 1 look like? Where does it go through? It goes through 1, right? So it's just a horizontal line, and it goes through 1. What is the x value where those two equations cross? You'd have to count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And you go up here, okay? And this is a point, 9, 1, right? And if I solve this equation algebraically, I would get the same thing. Watch. 1/3 x minus 2 equals 1. I'd add 2 to both sides. Would I? Yeah. And I get 1/3 x equals 3. And then I'd multiply by 3, x equals 9. Right? And you might say, why would I want to do that? I could just solve it algebraically. Yes, but like I said, if you have something like this, when you get to higher level stuff, if you do like y equals e to the x, and like if you had something like e to the x equals x squared or something like that, you would say, you don't have to know this now, but if you have y equals e to the x and y equals x squared, those can't be solved algebraically. So you have to solve them graphically, okay? And so sometimes the only way to solve an equation is using graphs, okay? Have we done enough for today? I think we should just start on your own. What do you think? Okay? Okay. So let's just, oh, wait, we have to do the thing on the other side, sorry. Let's just look at that thing on the other side real quick, okay? And then you can start on your own. I was going to do that activity, but I want to. So this is the same problem. This was supposed to be cut in half, but It's not. Let's look at this one. A contractor needs to build 2 straight roads, each passing through point A. One road must be parallel, and the other road must be perpendicular to Pine Street. Find the coordinates of a second point that the parallel road must pass through, and the coordinates of a third point the perpendicular road must pass through. So in other words, what you want to have on this is one road going like, kind of like this. So that's not really parallel, is it? That's bad parallel. Let's try again. One road that is parallel, there we go, going through that point, and one road that is perpendicular going through that point. And what they want to do is find one other point on this road and one other point on this road. Okay? So what I would do is find, can anyone tell me how I would do that? How would you do that, Jessica? I'd find the slope. That's what I do. What is the slope of this line? The slope of this would be 3/2. So if this is the point here, right, I'd go over 3 and up 2. I missed, okay? But this would be your new point. So the coordinates of that point would be, what are the coordinates of that point? What's the scale on the bottom? I can't see the scale on the bottom. What's the scale on the bottom? So let's go by tens, right? So 10, 20, 30, 40, 50, 60. And then, so this would be 60, comma, 20, 30, 40, 50, 60, 60. Would be on that road. Yes? Follow that? How about if I wanted to find another point on this road? If the slope of this is over, did I say 3? Yeah, 3/2. What would be the slope of this line? Opposite reciprocal. What would be the slope of this line? So this would be what? -3/2, right? So from this point, I would go over 2 and down 3 and find this point down here. Or I could also go backwards 2 and up 3 and find this point right there. Follow that? If it's got a slope of -3/2, I could go backwards 2 and up 3, or I could go forwards 2 and down 3. So any of those points would work. This one here, you can figure out what that one is, or that one there. Yeah? Did I go too fast on that? No? Okay, so I think I'm going to sign off here and let you guys